my first semester physics review. This is number 1. This is Ella. She weighs 500 kilograms and the bucket she's pulling has 10 newtons of force. First, we're going to list what we know. The 10 newtons and the mass of 500 kilograms. We're going to plug that into our formula. Acceleration equals force over mass. When we plug in what we know, we get 0.02 meters per second. Number 2. The annual game of tug-of-war is being played at the interclass games. The juniors are pulling with 60 newtons of force, and the seniors are pulling with 45 newtons of force in the opposite direction. What is the net force? To find the net force, we subtract the bigger force by the smaller force and find that there is 15 newtons of force going in the left direction. Number 3. Andrea is very bad at giving directions and trying to explain to her dad how to get to where she is. She travels 60 meters east and then 40 meters west. What is his displacement? We do 60 meters minus 40 meters to get 20 meters as our displacement, because displacement is how far you are from where you started, not how far you've traveled. Number 4. A bobcat in the wild runs 6 meters per second from rest for 2.3 seconds before stopping. What is its acceleration? First, we list what we know: the final velocity of 6 meters per second, the initial velocity of 0, because it started from rest, and the change in time, which is 2.3 seconds. We then have our formula: acceleration equals final velocity minus initial velocity over the change in time. 6 meters per second minus 0 meters per second over 2.3 seconds equals 2.6 meters per second squared. Number 5. We have 60 newtons, which is our x value, plus 45 newtons going up, which is our y value. We put that together to get our x, draw our resultant. Then we use a squared plus b squared equals c squared, plug in our values, plug it into our calculators, and get 75. Number 6. Moo Moo the puppy woke up from rest and started running to his food dish that is 0.8 meters away in 7 seconds. What is his speed? We list what we know, and then we plug it into the speed formula, distance over time, which gets us 0.114 meters per second. List Newton's first 3 laws. Newton's first 3 laws are the law of inertia, resistance to change. The second is acceleration, that is produced by a net force that is directly proportional to the magnitude of the net force, but inversely proportional to the mass. Number 3, action and reaction forces. For every action, there is a reaction that has an equal and opposite force. Number 8. An angry little girl throws her Barbie because it has the wrong hair color. 2.8 seconds later, it lands on the ground. How far away from her does it land? We know our time, 2.8 seconds. Our formula is dy equals 5t squared, and then we plug in what we know. When we plug it into our calculator, we get dy is 39.2 meters. Number 9. A pink Ferrari F430 weighs 3,197 pounds. How much is that in newtons? So we take that 3,197 pounds and times it by 1 kilogram divided by 2.2 pounds. We then cancel out the 2.2 pounds and we times that by 10 newtons over 1 kilogram. Then we cancel out the units. When we put that into our calculator, we get 14,531.82 newtons. Number 10. A downward force of 10 newtons and a force of 13 newtons to the right. Draw the resultant. So we have our downward force of 10 newtons and our right force, 13 newtons, and draw our resultant. We then use a squared plus b squared equals c squared, plug in what we know, and get the resultant of 16.4 newtons. Mr. Trombley is trying to show his students what the meanings behind graphs are. He waits for 2 seconds before starting. He goes 3 meters back and stays for 3 seconds. He then goes forward 5 meters and stays for 5.5 seconds. He quickly backs up in 1.5 seconds, 8 meters, and then goes forward 4 meters, stays for 2 seconds, and then goes back in his start position. What's his total distance traveled? Average speed? So we break down into increments and add up how far he has moved. We get 19 meters. The average speed formula is distance divided by time. And when we plug that in, we get 0.95 meters per second. We get the 20 seconds from the graph. Number 12. Pete the rubber ducky is moving across a 65-meter wide stream at 11 meters per second that has a downstream current of 4 meters per second. How long does Pete take to reach the other side? How far downstream will Pete end up? What is the velocity of Pete with regards to the shore? So here's a diagram of the stream, the 65 meters, which is our dx. Here's Pete in the 11 meters per second, which is our vx. And our downward 4 meters per second, which is our velocity in the y. How long? We use time. Formula dx divided by vx, which when we plug in what we know, we get 5.9 seconds. How far? We use d equals vx times time. We plug in what we know and we get 23.6 meters. For Pete's velocity, we use the 11 meters per second, our vx, and our vy, make a resultant, and use a squared plus b squared equals c squared, and we plug in what we know, and we get 11.7 meters per second. Number 13. An airplane is flying at 300 miles per hour, heading 30 degrees north of east. What are the magnitudes of north and east components in the velocity? So our east is our x and our north is our y. So we use cos to find our x. We plug in what we know, we plug it into our calculator, we get 260 miles per hour. For our y, we use sine, we plug in what we know, we plug it into our calculator, and we get 150 miles per hour. Number 14. A cannon shot at 60-degree angle with an initial velocity of 75 meters per second. What will be the max height it will reach? How far away will it land on the ground? So we have our 75 meters and our 6 per second and our 60-degree angle. We then use our cos 60. We plug in what we know and we get 37.5. Then we use our dx equals vx times time to find our dx. We plug in what we know, and how far it goes is 281.25 meters. For our dy, we use 5t squared. To find our max height, we plug in what we know, and we get 70.31 meters. Number 15 is a chart. The maximum velocity of basketball thrown in the air is 58 meters per second squared. Oops, not squared. Fill out the table. We have our angle and we have to find our Vx, Vy, time in the air, dy, and dx. We use our angle and our 58 meters per second to make a triangle. We use sine to find our y and cos to find our x. We plug in what we know, plug it into our calculator, and get our answers. Then for time, we use t peak, Vy divided by 10, plug in what we know, and then times it by 2 because t peak is only half the time that it takes to get to the peak. So we times that by 2 to get the full time. We get 2.014. And then we use dy equals 5t squared, plug in what we know, we get 20.28. And then we use dx equals vy times time, plug in what we know, and we get 20.28. That is the only one we get identical answers for dy and dx. We then do cos and sine over again for each of the degrees, get our answers, get our time answers with that t peak times, divided by 10 times 2, and our dy equals 5t squared, and our dx equals 5t, or dx equals vx times time, and we get all of our answers. Number 16. The cops in Law and Order are chasing a robber and accidentally throw their gun horizontally from a building that is 8 meters high. It lands 24 meters away on the ground. What speed is it thrown at? So here is our building. Our dy is 8 meters, and our 24 meters is our dx. We use dy equals 5t squared, 8 meters equals 5t squared, and then we divide it and take the square root, and we get our time of 1.26 seconds. We then use our speed formula, d over time, plug it in, and we get 19.05 meters per second. Number 17, a sitting box that is 7 kilograms has a net force of 10 newtons acted upon it. What is its acceleration? Now we are assuming that there is no friction in this situation. We use our force equals mass times acceleration. We plug in what we know. We have to get a by itself, so we divide by the 7 kilograms and find our acceleration to be 1.49 meters per second. Number 18, Number 18, a soccer ball is rolling off a locker room bench that is 2 meters high. It takes 3 seconds to reach the ground. What will be the speed when it hits the ground? What will be the average speed and the distance of the fall? So speed of free fall, we use acceleration times time. We know our acceleration is gravity, around 10 meters per second, times 3 seconds, we get 30 meters per second. Average speed, we get initial speed plus final divided by 2. So we get our 0 plus 30 meters per second divided by 2, we get 15 meters per second. Then we find our distance, average speed times time. 15 meters per second times 3 seconds gives us 45 meters per second. Number 19, I was swinging my legs off the chairs at school because they're too high. My shoe flies off at a 30-degree angle and lands in 1.09 meters from my chair. It had a horizontal speed of 2.2 meters. How long was my shoe in the air? What was the vertical height? So I drew this just to represent the situation. We got our Vx of 2.2 meters per second and our dx of 1.09 meters. We use our tan 30 to solve that, and we get 0.63 meters. Then we times that into, or we plug that into times, or to time equals dx over vx. We plug in what we know, and we get 0.49. 20. An Oreo rolls across the table at 6 meters per second. The ball then rolls off the table that is 2.5 meters high. How far in the x direction will the Oreo hit? What is the final velocity in the y? So here I drew a little diagram to show the situation, the vx and the dy. First we use dy equals 5t squared, plug in what we know, and then we find out that the time is 0.71 seconds. Then we use our velocity in the y equals initial velocity plus acceleration in the y times time. Our acceleration in the y is gravity and the time of 0.71 seconds, which gives us 71 meters per second. Then our dx equals vx times time, gives us 6 meters per second times the 0.71 seconds to give us 4.26 meters. And that is our physics review.